we're going to go ahead and get started with our webinar, Embracing the Digital Twin, and this is actually going to be part one of a two-part series. So for our agenda, we're going to start with by very briefly talking about who we are, and then we're going to jump into the topic of the day, which is looking at the digital twin. How can you embrace it? And we're going to ask a kind of provocative question. How can you create products and guarantee that they will not fail? We're going to look at our machines. Are they going to work as designed? And even talking about going down to the PLC level of a machine. For myself, my name is Dan Turk, and I'm an application engineer with Geometric Solutions. Now, just briefly about the company that I work for. So I work for a company that's called Geometric Solutions. We sell Siemens software solutions, and we're part of a larger company referred to as the Waltonen family. Included in this, we have at Waltonen Engineering hundreds of engineers. And then at Independence Tooling, we actually have the equipment, the machinery to build the things that we design. So if you think about it, from the start to the finish, we do it all. The owner of our company, he put it best. He said, our ability to successfully partner with our customers comes from our experience in using the tools we sell every day. So we're not just selling tools, we're using them. For today, we're here to talk about embracing the digital twin. And we're going to look at this on the machine level. So we're going to look at a tool called Mechatronics Concept Designer. Now to start with, I want you to think about a few questions. The first question, what type of PLCs do you currently use? NX Mechatronics Concept Designer is a Siemens product, but did you know that you can use it with Rockwell, Allen Bradley, Mitsubishi, Omron? The list goes on and on. You can use it with any type of PLC. How? Well, actually, we're going to get to that in part two. The next question is, what type of CAD software do you currently use? Are you using Siemens NX? Maybe Solid Edge? What about SolidWorks or AutoCAD Inventor? Whatever the CAD software, it works with NX MCD. So we just want to set the table with those thoughts. What you currently are using is going to work just fine. But now let's ask the question, what would you do if you knew that you could not fail? Would you jump out of an airplane, maybe climb a mountain, explore the world, try to change the world, or perhaps make a better you? But what if the things that you made, if you knew you couldn't fail? What would you make? A bullet train, a rocket, maybe a Mars rover? With Siemens and with the digital twin, you're actually able to right now create products that cannot fail. And that's because you're embracing what we like to refer to as the digital twin. With the digital twin, you can see everything, plan the details, prevent problems, close the loop, and optimize the system. With the digital twin, you can also adapt to new ways of working, gain flexibility, and even deliver the toughest jobs. And with the digital twin, it can be from your plant in Germany to your plant in Mexico with just one click of a button, and you're there. The digital twin, this new technology, it is disrupting everything. And if you want to make world-class products, then what you need to do is take the leap with a digital twin, conquer that mountain, explore the world, doing the best that you can with a digital twin to even make changes in the world. So how are we going to do all of this? That's the question. Well, that's what this webinar is going to focus on, is the digital twin, and specifically the digital twin for machine builders. So let's just ask that question. What is the digital twin? Well, you'll notice we have this nice little definition here. It's a digital replica of potential and actual physical assets, process, people, and so on. The digital twin is not simply a picture. It's not simply a cartoon. It's not simply a CAD model that's made in 3D, but it's taking all of the real pieces of information, all of the real physical properties, all of the electrical properties, and then making them digital. Now, if you're able to embrace the digital twin, then you're able to rocket past your competition. Because if you think about it, this digital model that we're looking at, this digital twin, it actually becomes the proof of concept. It actually becomes the prototype. So why is it important that you're on this webinar right now? Well, it's important because digitalization is changing everything. Gone are the days where the machines that you made were just mechanical. Now we have electronics, we have HMIs, we have controllers, we have all this extra stuff that's in there. So digitalization, it's disruptive, it's changing everything. And so you need to be able to keep up. When it comes to this virtual environment though, what are we talking about? Well, at the machine level, we're talking about taking the logic of the PLC, taking the HMI, and making those virtual. Taking the mechanical and then the automation system, virtual. And this can be done at a cell, a plant, or a line level. Siemens has all sorts of products to be able to embrace the digital twin at every single level. It could be that it's just the automation that we want to see a digital twin of. But we could take that up to the production machine with NX Mechatronics Concept Designer, what we're going to look at. But then you can even advance that to a robotic cell or even to an entire production line. So we're talking about the digital twin at every level. Let's take a moment though, and let's look at the digital twin for production machines. So what you're seeing here is your first look at NX Mechatronics Concept Designer, or MCD for short. And you can see that on the left. So this is the actual digital machine. And it's not just running, so to speak, cartoonish, but do you notice on the right what's actually controlling this machine, this digital twin? You can see it's actually a virtual PLC, and then you can see the tag table right behind that. And as things are moving and changing, do you notice the trues go to false, the falses go to true? That's because it's this program that is running the machine. What we're looking at here is a digital twin of a real machine. Why do you think it's important, though, that we embrace the digital twin? Well, we don't want to wait until we're here to realize that we got something wrong, or that our machine is not going to work as we designed it, or when we're in front of our customer and things are failing. No, at the digital level, we're able to test and ensure that what we're making will not fail. Again, what would you make if you knew you could not fail? Well, you could make a cool machine just like this. Over the past many months, I've spoken with a lot of different companies. And the companies today, they face some unique challenges. And I'm going to guess that most of you on this webinar, you have had similar, if not the exact same challenges. Just look at these one at a time. For the first one, we're in the midst of a global pandemic. Do you want to travel to some far-flung corner of the globe? No, nobody wants to travel because they want to stay safe. Or perhaps you want to win more business, take on more business, but you don't really want to have to hire a bunch of more folks. Or perhaps it's your customers. Their demands are ever increasing. They want one machine to be able to be retrofitted to do something else. Or perhaps if you're an automation engineer, boy, you guys are constantly getting squeezed with your lead times. Or when it comes to the actual physical commissioning, how can you ensure that there's not going to be any real risk? How can you ensure that during the actual commissioning that you will not fail? These are the challenges of most of the folks that we've spoken to over the past few months. Along with that, we found some other interesting marketing trends. One of the trends is that your customers, they are demanding lower cost and they want the machine built quickly. And it's not simply a matter of, well, I'll make it quick and cheap and it won't work very well. No, they still want a high quality. Something else that we've found is some of our customers are being told that they have to have a digital pre-installation approval. So they have to have a digital twin that their customer can look at, and that's what they're going to sign off on. And this has increased when it comes to the COVID pandemic, that they're trying to get these buy-offs from across the globe, not having to travel. And this is where the tool that we're talking about today, NX Mechatronics Concept Designer, where it comes into play. And what this tool, what it helps you to do is to get to the market faster. And you can use it in a number of different ways. You can use it at the concept stage. So just when you have an idea in your head, you can start to put physics properties. You can start to put tags, controls, everything, even to just some simple little lines. But then we can take that to the next level where you can have mechanical, electrical, and automation. You can have these three groups and they can actually work together. And then the icing on the cake is what we like to call virtual commissioning. And everybody knows what real commissioning is, when we're standing in front of the machine and hoping that nothing fails. Well, instead of standing in the machine and hoping, with virtual commissioning, you can ensure that the machine is going to work as designed, that the behavior is going to work as desired before you even cut a single piece of metal. Now let's take a moment and just think about the way that we're doing this now. So this is a typical workflow. Likely you guys are having the same thing in your company. Of course, you start with the requirements. You start making some concepts. Well, then mechanical design gets started, and along with that, some mechanical construction. So you get the machine ready to go, you start building it, and then electrical, they get involved. And lastly, automation comes into play. Then you get to the real commissioning. Now, the real commissioning is you're standing in front of that machine, hoping everything works. You might be at some far-flung corner of the globe. And then once that's done, and this process can take a while, then we start with production. But what if we could break this chain? But what if we could make it where it's not that it's one guy works, then the next, then the next? Well, with Mechatronics Concept Designer, we actually can do this. Because what we're able to do is have the mechanical, electrical, and automation actually work together. Now that might seem interesting because right now they don't work together. In fact, as a mechanical engineer, I can't tell you how many times I've told the other groups, you're just going to have to wait until we're done. But if you have this digital twin, just like that model that we saw a few minutes ago, now you have something that the electrical designer, he can use, or the automation engineer, they can get started as well. And what that's going to do is cut down the amount of real commissioning that we would have. There's always going to be some real commissioning. If you just think about the plant where your machine's going, what if the concrete wasn't poured just so level? Well, you're going to have to make some tweaks. But imagine if the majority of the issues, if you got those ahead of time. That's the digital twin. So some of the examples, or the advantages rather, of virtual commissioning. Now the first one is teamwork. Yes, that's cliche, but actually mechanical, electrical, and automation, they can work in parallel instead of serial, which is how they're doing it now. So now they may like each other, but it's not really so much of a team. That changes with virtual commissioning. Or being able to reduce costs due to errors. So you can find out, is your code right? Is the machine going to work the way you designed it to ahead of time? The third point, reduce risk during the commissioning. Now I have to say, as I've talked to a lot of different companies, I've heard some hilarious stories about what they do to mitigate risk during the commissioning. Now some, or I should say the majority, their number one thing is they don't sleep well the night before. One company in particular, they actually had one guy, and his job was to stand with his hand poised over the e-stop button. And if he heard a loud bang, or if he heard someone yelp, that's what he was supposed to do, is hit the button. Can you imagine that was actually someone's job? With virtual commissioning, you reduce that risk. You're able to test the what if scenarios. Well, what if the machine doesn't work? What if this sensor goes down? And you can just imagine how much time that's going to save you with debugging. Another advantage with virtual commissioning is you can train your customers, you can train the operators before the machine is ever shipped. You know how on the HMI there's that big red shiny button that we shouldn't press? Well, with the digital twin, they can press it to their heart's content, because the only damage that would happen is on a computer. So there's no damage at all. Let's briefly see an example of how virtual commissioning can help us. Now here we have that machine that we looked at earlier, and what we're going to do is we're going to test the sequence of operations. So we just want to know, is this going to work? And what we're doing is we're actually bringing in the tags and the signals from our PLC. So we bring those in and link them up. And in doing so, it's the PLC that's running the model. So it's not cartoonish, or it's not fake. No, it's the real PLC that's running everything. So we can hit play, and we can see that there's a little bit of an issue. So you'll see it's picking up that gear, but it's just not working quite right. So what's nice about this, on the right, you can see this is the Siemens version, so it's the TIA portal. We're able to go in to those function blocks and change around the code. So we're just going to have this virtual PLC, it goes online. And then what we do is when we run the model, as it starts to move around, you'll notice on the right, you can see where it's at, because this model is based on a sequencer. So we can identify, okay, there's a little bit of an issue here. So we validate the code, and then we just fix it. So in this case, essentially, we're just swapping sequence number 4 and 5. We'll load the code back into the virtual PLC. And then let's see if it worked. So we'll hit play again. And look at that, it worked just fine. See, the cool thing about this is we're able to make sure everything is going to work ahead of time. We didn't have to wait until the machine was built, until everything was in front of us, and ruin a bunch of parts. See, that's one of the nice things about virtual commissioning. Now, with virtual commissioning, you can just imagine how much it's going to lower risk. Remember, we talked at the beginning of this, what would you do if you could not fail? Well, without virtual commissioning, what do we get? A lot of failures. There's extra time, extra personnel, extra materials. If it's an international project, who knows what the costs are going to be associated with that. But with virtual commissioning, see, we're able to test and eliminate the errors ahead of time. What we just saw a second ago, we got to see that it was just one simple piece of code was in the wrong spot, no problem. We didn't have to ruin anything to identify that problem. We can also train the personnel before the machine is built. And then that model that we just saw a second ago, well, you can use that for validation or just to promote your company. See, with virtual commissioning, what do we really get? Well, we get known issues, known costs. Essentially, you're building a machine that cannot fail. And this is important because the Six Sigma quality, the rule of 10, most of you guys already know this, I'm sure, but it's just that wherever you can find the error, the next stage up, it's going to cost more by a factor of 10. So think about the machine that we just looked at where we changed that code around. How much did that cost? Didn't cost anything. But if we waited until the machine was built, how much is it going to cost? And that's just one simple little example. So the question then is, how can we accomplish our goal? Well, the way that this works is we take all of the mechanical pieces. So that's the kinematics, any robotic programs, mechanical sequences. We're taking that physical portion, and then we take all of the electrical pieces. So this would be the PLC, the HMI, the I/O, safety, diagnostics, all of those things. We take and we bring them together. And what does that give us but a digital twin? And a digital twin that we can do virtual commissioning on. So then we have this model that we can evaluate the mechanical and the electrical system behavior. Again, what are we talking about? We're talking about being able to have a machine, to have a product, and it doesn't have to fail. And just to conclude this, why is this so important? Well, as we said, it's important because digitalization, it is changing everything. And that's why we want to be here to talk about our virtual commissioning and what we can do. I'd like to just end it by showing this little slide here. You can see that there's a QR code that you can scan where you can learn more about geometric solutions, more about the digital twin, and more about our upcoming webinars. I'd like to take this time to thank all of you for your time and attention. Everybody, have a great day and stay safe.